for this specific paneling formats, what we are trying to use is basically using the LunchBox paneling tool and hexagonal panel in order to create this form on our surface. So that's the goal that we are trying to do. So when you bring in a hexagonal panel from the in a Grasshopper, the input for that, obviously the surface, the U division, and then the V division, and the outcome of that will be the panel itself, or the cells and the vertices. So I'm going to go to my Grasshopper, and after install the package of LunchBox, what I would do is that I will go onto the LunchBox, and under the panel, and I'll bring the hexagonal cells. So that's going to be my first course of action. I will use the surface. I'm not changing the U or V value. I'm going to keep it as 10 as is. But yeah, I'll encourage you to adjust these different variables to see the differences in this like a format of the form that you see. So what I get out of it is basically this like a hexagonal pattern, and also the center point of them, correct? Now, because I'm trying to create the pattern of just the hexagon, if you look at it, if you pay attention, you see that there are some places here that I have forms that is half or quarter of hexagon, and I don't want them because later on my algorithm is going to be messy. So I have to filter them out before going anywhere else. So what I would do is that I'm going to go over here. I'm just using the explode to explode the cells, right? I got the cells and I explode them. Now I have the segments, right? So I'm going to use the length of list, or list length, to get the length on each of these. So if you look at it, on each of them I have the length of the list. Now what I want to do is that I want to evaluate this before moving forward. I'm going to use this expression and put it here. My expression, if I zoom in here, I'm going to remove that, only has one value, and the value has to be either x is equal to 6 or not, meaning that if there is a 6 side for that hexagonal elements that exist there. So I'm going to use that, and I'm going to connect the list here to the. So if you look at my data points right now, what you see is that if I just flatten that data, see that I have false, 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 true, 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 depending on the location of those hexagons. Now, in order to remove the cells that are not hexagon, I'm going to use the call pattern, right? So what is my pattern? The list is going to be the cell itself. And also I have another one. I have the center because I'm going to use the center later on. So I'm going to have the center as well. The pattern for removing item will be coming out of this expression. So this is going to be the pattern for these two. So if you look at the list that goes in there, it's 61. Now I'm filtering it, and it's going to be 41 out of those 61, like a hexagon that I had before. Now that's all set. I'm going to use the cell itself. I'm going to scale it first time. So let's do the scale. And the geometry is going to be this, the geometry, the cell itself, and the center will be the center that I have. For now, I'm going to use a factor that is going to be 0.6. Later on, we bring the attractor point to adjust it. So if I go back to my form, you see that now I only doing the scale on the cells that are hexagonal for. So that's going to be the first part, right? Now, what I need to do is that I need to basically loft this part, because the loft will create a surface right here. See that that part is going to be creating the surface right there. So I'm going to merge these two data, one of them coming from this first scale, and then the second one coming from the first cell that I have before. And I'm going to do the graph before I doing anything else, because I want to put one of them on, I want each of them to be in one graph. So I'm going to click here, I'm going to graph this part, and I'm going to graph the other one as well. So I have these two graphed. So basically the outcome of this will be on each branches 2 sets of data. Now I'm going to perform the loft. So if I go back here, you see that now there is a surface that created based on the original hexagon and the second one. All good so far? Now we need to do another scaling, right? So let's do the scaling first, and then we're gonna move that. So let's do the second one. The second one I'm gonna do is gonna be 60% of this one as well. So I'm gonna use the scale again. The geometry will be the second cell, connecting it to that scale. The center doesn't change, right? The center will be the same. So I'm gonna connect the center here, and I'm gonna put 60 here. I'm gonna connect it to this part. Now I'm gonna check. I have the second hexagon in the center of it. Now we know that we want to move this down, and for that we need a normal vector data on that specific point, which is the point on the center of each cell. So what I will do is that I'm going to use the eval surface. So my surface is going to be the surface that I had before with this loft. I'm going to put here, I'm just going to put surface, connecting that, and then bring it all the way here. Avoid that is messiness. I'm just right click here and then change the display to hidden. So that's going to be my surface, and I'm going to put reparameterization on that, and I'm connecting that here. So what is going to be the UV value? I need another things, right? What is that UV value? I get it. I get that UV value based on the closest point from the surface. You remember that? Right. So we're going to use the closest point to the surface, not that, closest point to the surface, right? So what is the surface? Let me just copy and paste that. I have it here. I'm connecting it to the surface, and my point will be the center point that I have before. So I'm going to connect that here. Now I have the UV of all those points. I'm connecting it to a UV value here. Now, the only thing that I need from here is that UV value, that is, sorry, the normal vector data. So you see that I get the list of 41 vector data. So again, we know that sometimes this normal is going to be high or low, and we want to make sure that is the right amount that we have. So we do the multiplication. We put the multiplier here, and then connecting that vector data and adding, let's say, 0.2 for now. Just connecting that 0.2 here to this normal data, and everything looks good. I have to use that for moving this object that I have. So I'm going to use move. The geometry will be this part that I just scaled, right? Correct? And I'm connecting it here. And then the vector data comes from this part. So let's go and check what we have so far. I have to hide so many things. So let me just hide all these things that I have here. I'm going to hide them, preview off. I don't need that either. So I'm going to turn the preview off here as well. Just go back and then see where the location of that. Okay. So far looks good. Now the problem here is that let's try to do the loft. Let's try to do the loft and see what's going to be the outcome. So I'm going to use the loft, and I need a merger for that. So let's do the merge. So if I use the previous cell, which is going to be the first scale, and then use the second one, and then even I do the grafting on it. Graft here, and then graft here, and then connect that to the loft. Let's check the outcome. The outcome of it is not the one that we expected to have, right? So if you look at the, the outcome of it is not what we expected to have, right? Because we're looking for something that is, oh no, not this one, sorry. Confused myself. This has to be. So the first is scaling here and the second is scaling here, right? It's gonna give me that loft that I'm looking for, right? So this one is correct. We got the first surface, we got the second surface. The only mistake that I made was that I connected this scale one to the one that I moved. So we need the outcome of the first scale and then connecting it to the part that we moved so far. So far we have the first surface, we have the second surface. Now we need to do another loft here, right? The challenge here starts with that we have this 6 side. So I need to first explode those surfaces in the smaller part, which is, let me select them so we can see. We need the outcome of, you see that these parts here, I need to perform the loft on each individual to create this surface at the bottom. Otherwise, it's going to be a very messy, like a loft. So what I would do is that I'm going to go over here and I'm going to explode the cell that I have for the last part. So now I have the segment of them. In each of them, I have 6 items, right? So let's get the item from this. I'm going to use the item, list item. And then here, what I would do is that I'm zooming here, and I know that I have 5 items that I'm looking for. 1, 2, 3, 4. And I'm clicking to bring in that all items that I'm looking for. So now that I have my surface, my basically segment, I'm connecting them here. So if you look at here, on each of these branches, I got only 1 item from each of those lists. So let's bring this here, and then now we're gonna do the merge on them. So on the merge, we need 2 different merge. We're gonna basically connecting 2 points, 2 of these surfaces together. So I'm gonna use the 4th item, and then connecting that to the to this merge here, and then from the first list I'm gonna use the 2nd item. And I'm gonna graph them so each of them will be on each branch. So when you look at the outcome, what I have is that I have 2 items on each basically branches. I do the same thing, but this time I'm going to use the 1 and 5. So 1 and 5. And if I look at the outcome, you see that I need to graph them. So making sure that grafted. Then this one is also grafted. So the outcome will be 2 on each of them. Okay. Now let's perform the loft on it. Connect this. That's going to be my first loft, and then the second one will be this. So if I go back to this, you see that the problem is that the outcome of that loft is not what I was looking for. See, it's kind of look like that these 2 curves are flipped from what they're supposed to be, right? If you recall, when the curve direction is not right, the outcome of the surface won't be the right one. So what I need to do is that basically I go here and flip one of the inputs. For example, for this one, I'm going to flip the curve number 4. So I'm going to use flip curve. And connecting the curve number 4 here, and then connect the outcome to this. Let's check what's the outcome. You see that now that the direction of the curve is correct, the surface that I created is correct. And I will do the same thing on the other one. So this time, I'm going to use the line number 5, and then connecting this to this part here. And then let's look at that. So basically, we get from this 6 side, we get only 2, and then we use the loft to loft them. And then that's create the last surface here. Part of this, what I'm trying to do is that I'm trying to adjust the scaling factor in a way that is related to a specific, like a attractor point, which the attractor point is -7, 7, and 2. So I'm going to go back to the Grasshopper, and I'm going to zoom out somewhere here because that's where I'm going to do the first scaling. So I'm going to put the attractor point first. So I'm going to put -7, 7, 2. That's going to be my point. And I'm going to use the distance to get the distance from this point to all the center points. So we have to use the one that we got from the call pattern. We're going to connect it here, and then we're going to get this part here. Now, if you recall, sometimes we got the value, but the value that we got from the distance is usually big, or like it's not the range that we're looking for. So first of all, we have to find the band, a bound between the numbers, the maximum and minimum. So we're going to use the bound, and then we get the distance, put it here. So that's going to be the boundary between 1 all the way to 11. Now, we know that we are going to use the remap. And remap number, basically get the number, get the variables, and then based on the source bound and then the boundary of the target one, it just remap the numbers. So I have the numbers that are the distance. I have the boundary of the source, just connecting it to this part. And then I'm going to create a domain, right? I'm going to construct a domain. And for my domain, I know that it's a scale factor, right? And the scale factor is not something that goes beyond that, like a 0.4 to 0.6 specifically for this like example. And it could be different, but that's what I put here. So 0.4 and then 0.6, and then that's become my boundary here. Now I'm going to connect that to the outcome, to the target, and then you see that the range of the number changes and is remapped. Now, let's check the form first. So the form that I have for now is right now is something like this, and I'm gonna use this remap number and then connecting it to the scale factor. And if I go back and check, you see that depending on the distance, it's kind of change, and you can adjust with the number and work with the number to get a different like a remap. And then maybe you want to do the same thing for the second one as well.